Hi everyone, now we're going to talk about curved mirrors. In a curved mirror we have two cases. One is a concave mirror and the other one's a convex mirror. In a concave mirror, the reflecting side is the inside of the sphere, and in a convex mirror, the reflecting side is the outside of the sphere. This is the primary axis in both of them. This is the center, and this is the focus. In both of them, it's inside the sphere. But when we're representing the mirror, we draw it like this. We don't draw the whole sphere. In a concave mirror, and in a convex mirror also, this is the radius. From the center to the vertex, it's called the radius. And from the focus to the vertex is called the focal length. And 2 times the focal length equals the radius in all of these curved mirrors. So here are the concave mirror special rays. In the concave mirror special rays, there is one rule that's very important. It's that an image forms in a mirror obeying laws of reflection. So what is the law of reflection? It is that the angle of incidence is equal to the angle of reflection. I'm also going to show this in the examples here. These special rays will help me find the image of an object in a mirror. So they're very important and I'm going to use them all the time. Let's start with ray number 1. Ray number 1 says that a light ray that comes parallel to the primary axis passes through the focus. This is the primary axis here. And okay, so this ray is parallel to the primary axis. It reflects from the focus. But how do I know that it reflects from the focus? It must obey this rule. So I'm going to check that by drawing a normal line. Draw it from the center. And then now I can see that this angle of incidence is equal to this angle of reflection. In ray number 2, I'm going to do the exact opposite I did right here. I'm going to send my ray from the focus. And this is going to reflect parallel to the primary axis. Okay, to check that, I'm going to put a normal line from the center. And I'm going to see that the angle of incidence is again equal to the angle of reflection. Here in ray 3, I'm going to send my ray from the center. So what happens when I send my ray from the center? It's going to reflect back the way it came. Because of the rule of the laws of reflection says that my angle of incidence, if it's 0 degrees, it's going to come back with 0 degrees as the angle of reflection. Okay, so ray number 4, I send my ray from the vertex to the vertex. This is the vertex of the mirror. And it should come back like this. Why? I'm going to see if it verifies my rule right here. Draw my normal. This angle of incidence is equal to this angle of reflection. Okay, so these are my 4 rays. These special rays I'm going to use to find the image an object forms in a concave mirror.